Hello, everyone. My name is Tom Horan, and for my sports movement project, I will be going over the Power Clean. Now, the Power Clean is a full body exercise. It encompasses six major joints to include the ankle, knee, hip, shoulder, elbow, and wrist joint. The Power Clean is intended to increase an athlete's power, develop their rate of force production, and this stimulates their fast twitch muscle fibers, also known as the type 2X muscle fibers. It promotes explosiveness at the hips, knees, and ankles by requiring a forceful triple extension to get in this position. And it correlates well with anaerobic sports. When implementing into a training program, you're going to see a lot of translation for an athlete that does participate in an explosive sport such as football, because this is a very explosive movement. So some of the topics we're going to cover is the overview of motion, physics principles, joint movements, biomechanical principles, considerations to increase efficiency, common injuries, and summary. Now, to begin, we're going to talk about the Power Clean and the 5 phases of the Power Clean and go over the motions of each phase. And we'll start out with the first pull, then we'll go into transition, second pull, catch, and then downward movement. Now, I have a short video that shows me actually doing a Power Clean where it has a quick, video of it, and then there's a slow-mo where you can kind of see the different phases of the clean. So first pull, transition, second pull, to the catch, and then downward movement. Sorry about that. So during the first pull, the whole point of this is to get the bar just below the knee. We're going to actually just get the bar moving. So we are going to set up in a deadlift setup where the shoulders are just over the bar is over the midfoot, and we're going to brace our core, glutes. We're going to externally rotate that femur, and we're going to have our back contracted, stabilized, and ready for the movement. So we're going to engage the latissimus dorsi and trapezius muscles. Now to begin, you are going to have your arms in full extension with a neutral spine, and we are going to begin the ascent with the hip and knee extension. Now during the transition, this is going to prepare you for the second pull where the triple extension comes into play. But just before that, this is a movement where we have to clear the knee. So as the bar is tracking up our shins, our knee is going to be in the way. So we have to quickly get over that knee, and you want to travel up just above the knee, below the mid-thigh, and you're going to have your feet flat on the floor. We're going to continue extending the hips and knees. However, your arms are still fully extended, and we are starting to have some slight thoracic extension. Now, the second pull is where the power triple extension comes into play. So we're going to have an explosive extension at the hips, knees, and ankles. And as you see, my ankle is off the floor, so we're in plantar flexion at this point. My knee and hip are almost at full extension. My thoracic spine is also becoming extended, and there's bar contact at the mid to upper thigh, and this is coupled with a forceful shrug and some elbow flexion that is going to get the bar up to its highest position. Now, during this movement, you do want the bar path as close to the body as possible, which we'll talk about later, and how that is going to affect your moment. Now, during the catch, we're going to be getting into a front rack position. So for that, in order for that to happen, with the elbows pointing forward, we're going to need some external rotation here at the shoulder. The bar is going to be resting on the shelf of the clavicles and anterior deltoids. The heels will then regain contact with the floor, and then we will have flexion at the hip and the knee to absorb the weight during the catch. And then after a successful catch, you will then regain full extension of your hips and knees by getting into a standing position. And you're going to continue to brace the core and maintain that neutral spine and keeping your head straight ahead. Now, the downward movement in the video, I'll perform more of a drop where basically you're going to rotate your arms back over the bar, and you might have to have a quick jump posteriorly backwards. Allow that body to get clear of the way from the falling weight. And typically this would only be done if you have appropriate equipment where you have some buckle plates. And here at this particular gym, they did have some rubber weights that do allow those weights to be dropped. You also have a reset during the downward movement where if you're going to complete multiple repetitions, this will allow you to do that. So for the reset, you would rotate your arms back around over the bar. The bar will be removed from the front rack position. And as the bar is starting to come down, you might have to re-grip all 4 fingers and thumb around the bar, because sometimes during the front rack, you might only have a couple fingers actually gripping the bar. So re-grip the bar, get the bar to your lower or your upper thighs, and then you're going to perform an eccentric deadlift and return to the starting position. Now, we are going to take each of those phases and apply them to Newton's laws of motions, but I wanted to quickly go over each of the laws first to kind of go into detail about Newton's different laws. So Newton's first law is all about the inertia, and which is an object's resistance to a change in motion. So basically, the heavier the load, or the greater amount of mass an object has, the greater the inertia will be, and which means that the more force will be required to overcome that resistance. Now, in an angular sense, you're going to have mass moment of inertia. So that is the resistance to rotational acceleration about an axis. This can be computed by mass times the radius of gyration. And the radius of gyration is the distance from the axis of rotation to the center of mass. And so therefore, the greater the radius of gyration, the greater the mass moment of inertia. Now, how does that apply to the power clean? Well, to begin, the heavier the load that's on the bar, the greater the resistance to the change in motion that there will be. So to overcome that, you're going to need sequential force production that's greater than the load in order for the movement. And if the bar, let's say, is 200 pounds, then if I need to create a force that is over that of the bar. So if I create a net force of 201 newtons, then theoretically the bar would move at that point because I have overcame the inertia of that object. So also you can see how this is applied during the first pull, which is going to be overcoming that bar's resistance to change in motion by lifting it off the ground. So in the very beginning phase of that lift, the whole point is to get the bar moving. And this is typically the slower movement, because as you get through the different phases, your acceleration will tend to increase, and then you're going to have a little bit more force and speed through the movement. Now, Newton's second law, this is the force equation. So mass times acceleration equals force. So either the greater the amount of mass, the greater force there will be, or the greater the acceleration, the greater the force. And those coupled will create more force. Now, in an angular sense, the moment of torque is at play, so which would be the product of the moment of inertia and the angular acceleration of an object. And then also you have a moment arm or a lever that is derived from Newton's second law. So that is the product of linear force and the perpendicular distance between its line of action and axis of rotation. And we're going to talk more in depth about that later on in the PowerPoint. So how is the second law applied to the power clean? Well, during triple extension, the bar is closest to the body. So we're going to be decreasing the moment arm, resulting in less force required to generate movement. And the body transitions to full extension, increasing the force level resulting in greater force. And this will also create the most acceleration in the lift, resulting in greater force applied. And lastly, Newton's third law, which is to every action, there's an equal and opposite reaction. And once again, for angular, for every applied moment, there is a second moment that is equal in magnitude yet opposite in direction. And something that also derives from the Newton's third law is the conservation of angular momentum, which we will talk about and how that's applied to the power clean. So during the first pull for Newton's third law, there is force applied into the ground, which is going to cause an extension of the hip and knee, forcing the body away from the floor. So we're putting force into the ground that's going to propel us backwards away from the floor. So during the second pull, where we are attempting to get the bar at its highest point, the center of mass is going to move forward, causing the body to enter into a slight overextended position from a flex position. So moving that center of mass forward, that's going to take us from that extended position to a flex position. And that's where we are going to have our elbows up and prepare ourselves for the catch. Now, during the catch, when we are absorbing that weight, absorbing that load, okay, there is an equal and opposite reaction onto our spine. So we're going to have axial loading, and then there will be in return flexion at the hip and knees, which was required to absorb the compressive forces of the load in the front rack position. Now, the different joint movements, there's quite a few, and there's a lot of muscles and a lot of joints involved. We're going to first start out with a lot of the primary muscles that are used. I have 5, which are the quadriceps, hamstrings, glutes, trapezius, and gastrocnemius. And we are going to discuss the origin, insertion, action, and the class of levers for each of the muscles. So to begin, we are going to talk about the quadriceps and how they are broken up into 4 segments, where all 4 segments are going to be a class 3 lever, and they are responsible for knee extension. However, one of them is responsible for knee extension and hip flexion. So to begin, we'll start with the rectus femoris. This is the one that is responsible for hip flexion and knee extension, not just knee extension. And that insertion point is at the tibial tuberosity via the patellar tendon, and it originates at the anterior inferior iliac spine. The vastus intermedius is once again class 3 lever, and it produces knee extension. This inserts at the tibial tuberosity via the patellar tendon as well, but the origin site is at the anterior femur. Now the vastus lateralis, once again, knee extension and class 3 lever, and it also inserts at the tibial tuberosity via the patellar tendon, but the origin for this muscle is at the linea aspera. And similar to the vastus lateralis, the vastus medialis also originates at the linea aspera and also inserts at the tibial tuberosity via the patellar tendon, and also it produces knee extension, and it's also a class 3 lever. All right. Now, for the hamstrings, similar to that of the quadriceps, there are different segments that make up the hamstring. So to begin, we're going to talk about the semimembranosus muscle, and this originates at the ischial tuberosity and inserts at the posterior surface of the medial condyle of the tibia. And its action is the hip extension and knee flexion. This is a class 3 lever. All these muscles I'm going to be talking about are class 3 levers. So the semitendinosus, this originates at the ischial tuberosity. It inserts at the anterior-medial surface of the proximal tibia, and its action is hip extension and knee flexion. And lastly, biceps femoris, the long head, originates at the ischial tuberosity. However, the short head originates at the lateral lip of the linea aspera. And the insertion point is at the fibular head for both of the heads of the biceps femoris. and the action is hip extension and knee flexion for the long head, whereas the short head assists in knee extension. And these are all class 3 levers. Moving on to the glutes, we have gluteus maximus, gluteus medius, and gluteus minimus. They are all class 3 levers, and they also are going to have some different actions and different origins and insertion points. So the gluteus maximus, this one originate at the posterior sacrum and ilium. It inserts at the posterior femur, distal to the greater trochanter and iliotibial band. Its action is hip extension, hyperextension, and lateral rotation. And it's once again class 3 lever. The gluteus medius originates at the outer surface of the ilium and inserts at the lateral surface of the greater trochanter, and its action is hip abduction, abduction. And the gluteus minimus, it originates at the lateral surface of the ilium, and the insertion point is at the interior surface of the greater trochanter. Its action is hip abduction and medial rotation, and once again, class 3 lever. And to finish up with our primary muscles, we have the trapezius muscle, more specifically the upper trapezius muscle. This originates at the occipital bone and thoracic vertebrae. Originates at the clavicle and acromion process. It's responsible for elevation with the scapula and upper rotation, and it's a class 3 lever. And the medial and lateral gastrocnemius originates at the medial and lateral condyle of the femur. An insertion point is at the posterior calcaneus. Its action is plantar flexion and dorsiflexion. However, this is one of the few class 2 levers in the body. Now, for the joints, we know all the primary muscles are. Now, the muscles are going to cause the movement at the joint. So the different joints that are at play, we have 6 of them, are going to be the talocrural joint, which is the ankle, the coxofemoral joint, the hip, glenohumeral joint, the shoulder, tibiofemoral joint, the knee, the elbow joint, which is comprised of 3 joints, which would be the humeral ulnar joint, humeral radial joint, and proximal radial ulnar joint. And lastly, the radiocarpial joint, which would be the wrist. In each of these joints, we're going to talk about the degrees of freedom, their action, and also the plane. So for the talocrural joint or the ankle, there was only 1 degree of freedom. It's responsible for dorsiflexion and plantar flexion, and it moves in the sagittal plane. The coxofemoral joint, the hip, has 3 degrees of freedom, and it is responsible for flexion, extension, abduction, adduction, lateral and medial rotation, and therefore it moves in all 3 planes, so sagittal, frontal, and transverse. The tibiofemoral joint, the knee, has 2 degrees of freedom. It produces knee extension and knee flexion. And there is some articulation with medial and lateral rotation, but not much. And so therefore it would be moving in the sagittal plane and somewhat of the transverse plane. The glenohumeral joint, the shoulder joint, has 3 degrees of freedom. It has flexion, extension, abduction, adduction, lateral medial rotation, and circumduction. Because of those planes and movements, you are going to have the sagittal, frontal, and transverse plane. The elbow joint, which would be the humeral ulnar joint, humeral radial joint, and proximal radial joint all in one, has only 1 degree of freedom, and that is going to be flexion extension. However, there is going to be some pronation and supination that is involved. So you can say these movements are done in sagittal and transverse. And lastly, you're going to have the radiocarpal joint, and this joint only has 2 degrees of freedom, and it produces flexion and extension, AB and adduction, and it moves in the sagittal and frontal plane. And lastly, with the joint movements, there are a lot of stabilizers and secondary muscles, but to name some important ones, we have our core muscles, which were to include the transverse abdominis, the internal and external obliques, rectus abdominis and the erector spinae muscles, which also are going to help with assisting the hip extension. Latissimus dorsi is also going to help stabilize the core. However, during the front rack position and also with that first pull. Now, the rhomboids and the posterior deltoids, they can come into play during scapular retraction or upper rotation or humeral abduction as you are starting to get in the catch position or the second pull. That is when these muscles will come into play. Now, biomechanical principles. Some of the things we're going to talk about is proximal to distal sequencing, the mass moment of inertia, moment arm, and length and tension relationship. So proximal to distal sequencing. So during the second pull, where there are hip extension and elbow flexion, there's typically going to have the most proximal segment decreasing its velocity. Therefore, its most distal segment can increase in velocity. So in this movement during the second pull, you can see that the proximal hip joint negatively accelerates when entering into extension, causing the distal shoulder joint to increase in positive acceleration, abducting the arms, lifting the bar towards the chest. This bar, this will cause the bar to lift to its highest point, resulting in less distance traveled for the catch in a front rack position. Another proximal distal sequencing will be during the catch. Now, during the catch, the proximal shoulder joint will externally rotate, moving into a negative acceleration, causing the distal wrist joint to increase the acceleration to move from a flex position into an extended orientation. So this will create an optimal front rack position. So mass moment of inertia. Now, during the catch, the entire body is going to move from a fully upright standing position where it's fully extended to a rapid flex position at the hips and knees in order to lower the body to get in a good front rack position to get underneath that bar. So during this action, the radius of gyration will decrease, allowing for an increased velocity at the hip. This will allow the lifter to get under the bar much faster for the potential of a heavier lift. And also during the second pull to front rack phase, the elbow will flex in order for the shoulder to externally rotate at a greater angular velocity compared to an extended position. When the elbow flexes, the radius of gyration will shorten, allowing for an increase of angular rotation at the shoulder joint. So if you ever try to do a power clean and at the top of the second pull, if you take your merry time and try to rotate your elbows underneath and get in a good front rack position, if you're not fast with that movement, or you try to do it in a fully extended movement, you will not be able to get underneath the bar in a good amount of time. So decreasing the radius of gyration with the elbow joint will increase the angular velocity of the shoulder joint. All right, moment arm. So in this illustration, we're going to see how the power clean affects the moment arm, which is the product of linear force and the perpendicular distance between its line of action and the axis of rotation. So during hip and knee extension, each phase, you could basically see this as first pull, transition, second pull, and also more into that second pull right here. You're going to see a decrease in the moment arm, okay, and there will be more of an extension of the hips and knees. So this is going to result in less load at the axis of rotation. So if the coxofemoral joint is the axis of rotation and the load is in the hands and the bar path is right here, as the hip and knees become more and more extended, you will see that the moment arm becomes shorter and shorter and shorter, all the way to the point where there's basically no moment arm. At this point, there is going to be a less load on the axis of rotation, which would be the hip joint or the coxfemoral joint. So this is going to make the lift easier for this person because that moment arm is being decreased. So there's less force to be moved. Now, the length and tension relationship, this is all about muscle shortening and lengthening and possibly staying at the same rate during contractions. So during the first pull and transition of the power clean, we're going to have a concentric muscle action during the knee and hip extension. During the second pull, there's going to be a concentric muscle action during plantar flexion, elbow flexion, and scapular elevation. During the catch, there's eccentric muscle action during knee flexion, hip flexion, and dorsiflexion. Also, there's going to be an isometric muscle action with all stabilizing muscles while you're bracing the catch. And then you will have concentric muscle action during humeral lateral rotation and wrist extension. Now, during the downward movement, there will be an eccentric muscle action during elbow extension and hip and knee extension, and then a concentric muscle action during wrist flexion, getting that bar back over from the front rack position. Now, considerations to increase efficiency. So we're going to talk about stability, maximum effort, maximum velocity, and displacement. So stability. During the catch of the power clean, the wider stance that you have, the greater base support you're going to have. So it's going to make you more stable. And also keeping the bar closest to the body will align the center of mass, and you will have better control. During also the power clean, you are going to need maximum effort. So as the weights increase, you're going to have to overcome that inertia of the load. So you need to generate significant force into the ground to get the bar moving up. And then you are going to need sequential movements of all joints required. Just kind of like we talked about with the proximal and distal sequencing. So having a good sequence of all those movements is pivotal. All right, so maximum velocity is another way to increase efficiency. So once again, the proper sequencing of joints from proximal to distal. So for an example, performing knee and hip extension before plantar extension, that would be the most efficient way. If you try to get in a plantar flex position, you're not going to be able to generate as much force from hip to knee extension if you're getting up on your toes before you are extending at the hips and knees. And also a full triple extension before flexion at the elbow. If you are down at the ground and you're trying to rotate your arms and externally rotate that shoulder to get in a good front rack position and flexing at the elbow, you're not going to be able to do that until you do the full triple extension. Increase in velocity, you're going to need more acceleration because this is going to equate to a greater amount of force. So typically, a power clean is a sub-max load of the deadlift. That is because you are able to move at a higher velocity, which is going to increase that amount of force put into the bar. And displacement. So you want optimal bar height during the second pull. So you're going to decrease the distance required for the lifter to get under the bar during the catch. So from the starting position on the ground to where the bar is pulled to its highest, if you can increase that displacement for this particular set of the lift, it's actually going to make it easier for the lifter to get underneath the bar. Then also keeping the bar path tightest to a vertical line without horizontal deviation will result in a reduction in the distance traveled of the bar, which will be most advantageous for biomechanical efficiency. Now, some common injuries associated with the power clean. They're all overuse injuries, such as patellofemoral pain syndrome. This is mainly due to the rapid contractions during triple extension, followed by the eccentric loading during the catch. These are quick, violent movements that, with overtime and repetitive use, can cause injuries. So to combat that, you need to have adequate rest and recovery, and have an optimized training program that is going to set you up for success. Also, some things that you can improve upon is balancing um, the ratio of strength between your hamstrings and quadriceps, and also strengthening your glutes to assist in stabilizing the knee. Some other injuries you could see are elbow tendonitis. Once again, another overuse injury, getting in that front rack position. A lot of times, if you don't have a good range of motion with your shoulder and getting the elbows up, you're going to be placing a lot of force from that bar into the elbow, which can cause some tendonitis. So working on, lengthening the latissimus dorsi, and also getting good wrist mobility and doing a lot of wrist extension is going to help you get in a better position to help with that tendonitis. And then lastly, you can see some lumbar spine injuries, which once again would be an overuse injury. So some things for those, you can just have proper recovery time, suitable training programs, and then also strengthening the glutes and hamstrings to take load off the erector spinae muscles. So if you're back dominant and you're trying to get through that first pull and second pull, and you're not utilizing the hamstrings and glutes, which are going to help with that hip extension, you can definitely overuse some of your lumbar spine muscles. So in summary, the Power Clean is a closed kinetic chain, full body exercise. It increases the rate of force production. It's going to make you a more explosive athlete. It comprises of 6 major joints, 5 major muscle groups. So very highly technical movement. There's a lot of things at play there. You need proper balance and timing, which would include the proximal to distal sequencing. And obviously with the velocity, you want to increase your velocity or the mass to create as much force as possible to overcome that inertia. And then with the overuse injuries, with the fast rate of the muscle contractions, you can just mainly need some good recovery and optimal programming to maintain some safety and not get burned out with the Power Clean. So once again, that is my sports movement project, and I hope you enjoyed. Take care. Bye.